Good afternoon. Welcome to Engineers Ireland, everyone. My name is Roy O'Connor. I chair the Roads and Transportation Society, and today we're going to have a talk about enabling the electrification of transport from the ESBN. So we're delighted to have Dan Catanase with us here from ESB Networks. Before we get into the details of the presentation and introducing Dan himself, just a few brief housekeeping matters for you. For those of you who've been here before, it's all the same stuff. If you have a question during the presentation, please pop it into the Q&A section there. And if there's any technical issues, there's the chat function, which I'll do my best to address for you in the background as we come along. Other than that, Dan's going to be speaking for 30 to 40 minutes, depending on how he gets into the slides. I understand that thereafter the Q&A session can start, and I will triage those questions. And we anticipate that this will be all a 1 hour event. So we wrap up by 1 o'clock is the intention, subject to the number of questions coming through. So without further ado, I'll introduce Dan. Dan has a master's degree in electrical engineering. He's a chartered engineer with ourselves here in Engineers Ireland. He's over 25 years experience in electrical engineering in the areas of generation, transmission and distribution, including the strategy and asset management in the power industry. It's quite a topical industry right now, Dan. A lot of various aspects of the electrical network across Europe under pressure, pricing and so forth. It's certainly gained a lot of attention from sign-ups to this presentation today. So look, we're delighted to have you along. You're very welcome here to Engineers Ireland, and I'm going to hand the microphone and slides over to yourself. Can you hear me clearly?
I can, and look, thank you everyone. Thank you, Roy.
Off you go, Dan. I'll leave you to it. I can hear you. All good.
Okay, yeah, thanks Roy for introduction, and thanks everyone. I heard there are in excess of 200 people joining today, so look, hello, and thank you for taking the time to attend today's webinar. I also want to thank Engineers Ireland and the Road and Transport Society for the opportunity to present today on what's, as Roy was saying, a very topical theme, the electrification of transport and how ESB Network is enabling this. About myself, I think Roy has already introduced me, so probably there is no need for anything additional. I just want to say it's a great privilege to be here today and present on how ESB Networks is driving the transition to the net zero and is enabling the electrification of transport. As for the agenda today, I just want to provide a good cover of the general context of the electrification and in terms of the government climate action plan, a few policy documents, a few sale trends in EV sale trends in Ireland. And after that, just a few words about ESB Networks and how ESB Networks distribution system operator and asset owner, how we operate in this regulated business, our role, about a bit of electrification of heat and transport strategy we published last year. And after that, we'll be talking a bit of EV charging off street and public, as I understood that that's the main, would be a topic that everybody would be very interested about. I'll be talking a bit about how are we getting the network ready for this challenge ahead of us. The new connections process, I'll be finishing with a few words about the challenges and opportunities ahead. Just to put and talk a bit, as I said, about the Irish context and the policy landscape. As we all are aware, the Irish society and ESB Networks are facing interlinked challenges here, and the Irish society as a whole is facing the challenge of a generation. This has been ever more evident in the recent COP26 negotiations in Glasgow and the launch of the Irish government climate action plan in 2021, which sets out a range of targets and measures necessary for our society to truly commence with its transition to us living low carbon lives. As we know, in July 2021, the Climate Action Bill was signed into law, putting Ireland on a course to transition to net zero and achieve a climate neutral economy no later than 2050. Now, that means that Ireland is now on a legally binding path to net zero emissions no later than 2050 and 51% reduction in emissions by the end of this decade. What that really means, I suppose, on the electricity, just a few topics relevant for today probably are increased renewable energy, as we all know, wind and solar up to 80%, probably by 2030. And there is a support scheme for microgeneration, allowing homeowners to generate their own electricity, reduce emissions from electricity by up to 80% from the 2018 levels. And on the transports, also some very relevant topics, as you can see here on the slide. It's about expansion of electrification of bus and rail fleets with 1,500 electric buses by 2030, increase the number of EVs on the roads to approximately 1 million by 2030. And if you look at the potential abatement for transport, that represents approximately 50% of the 2030 overall target. So facilitating the electrification of transport will have a significant impact on delivering our 2030 targets, and ESB Networks' role is to make that possible. So it's a very challenging target, I suppose, for the whole society. I just want to talk a bit about the EV sales here in Ireland. In terms of that, the electrification of transport definitely is happening, and it's happening fast. What we have here is the private car sales in 2021, as you can see on the top graph there, and for January and February in 2022. And the summary of 2022 so far is very good. The pure battery electric vehicle purchases are up 282% in 2022 compared to the same period, January, February of last year. The plug-in EVs purchases are up 165% in 2022 compared to the same period of last year. Now, on the other hand, the fossil fuel vehicle registered so far in 2022, it's 15% less than the corresponding period last year. So this is good news, and is a visible downward trend on that. Also, the batteries and the BEVs and the PHEVs currently making up 17% of the new vehicle registration in 2022. So 17%, and this figure was 12% in 2021. So it's a huge increase. Now, based on the units sold, what we tried is to model how the EV uptake might look like. And as you can see, it's growing exponentially. So the blue line is the actual purchases, and the white dotted line is the model that we're trying to estimate. And the sales beat the model so far, so it's a steeper upwards curve in that regard. From the electricity networks perspective, it's important to know the areas with high penetration of EVs. And based on the publicly available data, we plotted the EV sales geographically here, and the darker the color, the higher EV penetration is in that region. You can see a lot around the East Coast Dublin area, Cork, and on the West Coast as well. Obviously, Dublin commuting area, it's probably the darkest on the map. Also, to keep all the new EVs on the road, and that will require additional electrical energy. And this graph is based on the previous slide with the estimated EV sales and assumes an average consumption of 20 kilowatt hours per 100 kilometer and an annual electrical mileage of 6,000 kilometers. Obviously, you can argue it could be more or less, but this is what our kind of model was, and obviously it's just a model, so it can be adapted. So, so far we established that EV sales are going up, and so the need for additional energy to power all new and existing EVs. And next we will discuss about, as I said in our introduction, about ESB networks and how ESB networks operate. So just I'd like to give you a brief overview of ESB networks, as probably not everyone in the audience is fully familiar with our regulated business. As part of the ESB group, we are licensed to build, operate, maintain, and develop the electricity network in the Republic of Ireland. And ESB networks build, operate, and the medium and low voltage electricity infrastructure, including distribution stations, overhead lines, poles, and underground cables. You can see on the right-hand side the extent of our network and the amount of assets in the network. Also, ESB Networks finances, builds, and maintains the transmission system under a license granted by the CRU, that's the Commission for Regulation of Utilities, and under the direction of EirGrid, which is the Irish transmission system operator. We distribute electricity from the bulk supply to users under the distribution system operator license, so the DSO, granted license by the CRU. Obviously, we are here to serve our customers, and our customers are at the heart of everything we do. We provide services to every electricity customer, irrespective of their electricity supplier. And from 2011 to 2020, we invested in excess of 5 billion to refurbish and upgrade the national electricity network, providing an improved and strengthened electricity network countrywide. Building on this work, by 2030, our network will be transformed to support our society on the journey to secure an affordable low-carbon future, using clean electricity to drive fossil fuel routes of heating, transport, and the wider economy. And we are a country rich in natural resources, and over the coming decade, we will see the electricity system radically decarbonize, with the Climate Action Plan targeting more than 70% of electricity from renewable. This means that low carbon electricity will provide Ireland with an opportunity to also decarbonize many other sectors of our economy, such as transport and heat, through the adoption of EVs, as we saw it, and heat pumps. ESB Networks will play a central role in making this a reality, to ensuring that the electricity distribution network, which serves our 2.3 million electricity customers, is prepared and equipped to adapt to meet the changing needs for our customers and support achieving Ireland climate action targets. I mentioned that ESB Networks operates under a license granted by the CRU, and every 5 years there is a cost and performance review, and the current price review, called PR5, covers the period from 2021 to 2025. Staying on the same theme, the climate change is one of the defining challenges, as we know, of our generation, and electricity has a transformative role to play in tackling the climate change. To this end, ESB is taking urgent and focused action to achieve net zero emissions by 2040, and putting in place the infrastructure and services to enable our customers and broader society to live more sustainable. And achieving net zero will require the deployment of new energy technologies at massive scale that are capable of providing reliable zero carbon energy when intermittent renewable power from the wind, as we were saying, or sun is unavailable. Electricity networks are playing an increasingly important role in enabling the mass adoption of low carbon technologies, including heat pumps, electric vehicles, microgeneration, and the connection of large volumes of renewable generation. This provides opportunities and obviously challenges for network providers and increases the requirement for capital investment in the network's infrastructure. ESB Networks wants to enable this transition and move rapidly to focusing on scaling at pace towards 2030. We have already published our electrification strategy, and we have plans in place to step up and deliver on what's needed. And you see on the right-hand side of the slide the picture of our networks accounting the renewable sources. This will be possible by a combination of wire and non-wire based engineering technology and market solutions. And when I talk about wire-based solution, that means investments in the physical electrical distribution infrastructure. The non-wire-based solution is another key project in ESB Networks that I'm sure you have heard about, and it's called National Network Local Connections that will enable new ways to operate our distribution networks. These wire and non-wire based solutions are basically the two sides of the same coin, and that work hand in hand for delivering a more robust, resilient, flexible distribution network to allow this large-scale adoption of low-carbon technologies. Just moving on, and as I mentioned, our strategy alongside connecting and enabling this high percent, in excess of 70% of electricity generation from renewable, we have a central role in facilitating the electrification of heat and transport. As we know, the main fuel sources for heat and transport currently are oil and natural gas, which are harmful to the environment. Transitioning both heat and transport to electricity is a key pathway to reducing carbon emissions. And ESB Networks, as I said in my previous slide, will need to facilitate our customers to connect in excess of 950,000 electric vehicles and 600,000 heat pumps to the distribution heat system by 2030. And that's a huge amount of new EVs and heat pumps. The distribution network has obviously considerable capacity to accommodate electrified heat and transport. However, there will be areas of the network which are already heavily loaded, or where clusters of electric vehicles or heat pumps emerge that will require the deployment of smart solutions or reinforcement or both. The electrification of heat and transport and the growth of prosumers participating in the operation of an actively managed power network will result in larger power flows through the distribution system, and the network must be prepared and must be resilient to cater for this. On our electrification of heat and transport strategy, we set three main strategic directions, and on the first one, what we do, we update relevant ESB Networks policies and standards to reflect the changes in the system arising from the electrification of heat and transport. We ensure that all external documents and guidance are clear, accessible, to remove barriers for customers when adopting electrified heat and transport. And we support the development of governmental national bodies and local authority standards, policies, and code of practices, and I'll come back to this. On the second one, it's about support processes for EVs and heat pumps, and for our customers adopting these developed guides, online applications, and tools that will enable customers to quickly and safely connect electric vehicles and heat pumps to the networks. And also, we ensure we engage with our customers and stakeholders to collect and share the correct data and information. Last and not least, it's very important to ensure the networks is ready and we improve and refine our forecasts. And again, I'll come back to this and I'll show you how. For electrified heat and transport, we use forecasts to proactively program the development of the distribution system, and we expand the suite of smart solutions toolkit. We develop new tools and procedures to enable the use of new innovative technologies and concepts. So this is electrification of heat and transport strategies available on our website if you want to consult it. Moving on to the EV charging topic, when we talk about the electrification of transport, the first thing that comes to mind probably is charging. It's EV charging. Now, in the past, or up until recently, one of the main barriers for EV adoption was the EV range. Now, recent research doesn't have the range anxiety on the top three concerns, both rather charging anxiety. And in the next few slides, we will discuss a bit more about charging options. As regards the EV charging, this probably can be split into the two main categories, home and workplace and public. And we will cover mainly the public. We will not cover today the home or workplace because that's quite straightforward. So we will focus on public charging, as this is a very topical subject, as we all know. And when we talk about public charging, we can again split this in three categories: is public on street, hubs, and apartment or multi-unit developments. And to be operational, public charging in general needs an owner, needs an operator, and an electromobility service provider. And sometimes all these functions can be fulfilled by the same entity. With what all public charging categories have in common is obviously the electrical infrastructure. And ESB Networks, as the distribution system operator, need to be ready to connect all of these chargers. And here on this slide is just the probably graphical description of the previous slide, where you can see the public, the semi-public, the domestic, different powers, and from home, typically 7 kilowatt AC, with public and semi-public from 7 to 22 AC, 50 DC, and the fast and high-powered chargers in excess of 150 up to 350 currently DC high-power chargers. So it's a combination of these, and a different location, obviously, from workplace to destination to hotels, taxi ranks, and so on. How do we prepare for this? I think I said it probably in a way, and I'm going to say it again. We engage with our customers and stakeholders. We develop new design and standards to cater for EV charging. We have a lot of innovation projects, and I'm pretty sure most of yourselves have dialed in one of these, especially the Dinger projects, where we tried EV charging, and we tried vehicle to grid, heat pumps, demand response flexibility, and that's really part of our national network local connection project. But also, as I mentioned, how we prepare is by developing and investing in the distribution network, and by taking mainly to approach a proactive network reinforcement approach and a reactive. And I'll come back to this a bit later with a bit more details. In terms of stakeholder engagement, I just want to say that we have very good relationship and close collaboration from local authorities. And we were parts of consultation groups when they developed the guide for EV charging documents, and similar with SEAI, very good and close collaboration when they developed different guides, and they release public consultations similar to the Department of Environment, Climate and Communication, also Department of Transports in the developments of the infrastructure strategy. Obviously, I've been saying about and mentioning the CRU, the Commission for Regulation of Utilities, which were in permanent contact, and also with Safe Electric. We have many specialists working in ESB Networks, working in different working groups with Safe Electric, and updating the wiring rules to cater for the new challenges of electrification of heat and transport. So we have very good relationship with all these stakeholders. Staying on the same stakeholder engagements, we have very good relationship also with the Electromobility customers, and it's great to see very many players involved in providing public charging services from street to hubs, and probably apartment chargers as well. Talking about getting our networks ready for this challenge, one of our strategic objectives in ESB Networks is actively readying our network for the transition to mass electrification of heat and transport. And we do this by both proactively and also reactively based, let's say, on customer feedback. For example, via phone calls to our customer care center. Through this combination of proactive and reactive approach, we drive work programs to invest and reinforce the distribution system. And as you can see there is an excess of 100 million euros allowance for this PR5 period between 2021 and 2025 to be invested in the LV networks. That's a huge amount of money for making sure we can cope with this mass electrification. Talking about the proactive low voltage system improvement, what we've developed here, we've developed forecasting tools, as I mentioned previously, that demonstrates where our distribution network needs attention, because we have money, but we have to see how and where should we direct our investments and reinforcements. And this way allows us to shortlist our medium voltage to low voltage transformers where network capacity may be a concern, because it's either close to or at capacity already, because the network is in an area where customers are already advancing ahead with choosing low carbon technologies that are powered by electricity. Also, what we do, we've done, and we're continuing to do that. We monitor our key LV networks areas. We've installed monitors on key assets to manage LCT, so low carbon technology impacts on our network, and we have this installed, and we still have them, and we will keep them for the next several years. Also, we employ smart solutions. We are prototyping new innovation transformers, and also, as I mentioned, we collaborate with our colleagues in National Network Local Connections and with our colleagues in innovation to learn from Dinger project. We review the design standards. We train our engineering officers with the new standards, and obviously, what we do, we deliver the LV system improvements. We have also made very good progress with the smart metering program, which will also enable the adoption of low carbon technologies in our homes. So I think it's a lot, and I think it's a good slide for everyone to see what we've been doing, and we are very, very busy in this area. Just that we have discussed what programs we have in place to ensure the mass electrification. The next topic is more on the probably practicality it's more practical on EV charging, and I will start with on-street charging topic. And when we discuss the public on-street charging, this is again could be implemented based on the particularities of the specific location. Here you can see probably it's a narrow street with the Croke Park Stadium background. It's a street without private off-street parking. It is an older urban area, probably with relatively old electrical infrastructure and unlikely any spare ducts for additional electrical infrastructure to be added. So in this case, there will be significant civil works required to install EV on-street charging points. Here, I just picked another location, and in this case, we have an urban shopping area. Here, the electrical infrastructure may have been upgraded. There is a little bit more space, both not sure if there is any spare ducting in place or even it was installed part of the previous civil works. So if spare ducting is not available, civil work may be again significantly install EV charging points. We have here a new urban housing area with new electrical infrastructure. And okay, there are private parking there, but also you can see the public area as well in the middle. So here possibly we have spare ducting is available, but civil works still be required to install EV charging points. Now ESB Networks capacity here should be available in the required location from the local substation in the housing estate. Being fully aware of the importance of this topic, last year, ESB Networks issued a public consultation regarding public charging. Also, we have revised and published the new code of practice, and this is available on our ESB Networks website, can be downloaded. And this code of practice provides guidance for connecting EV chargers to the distribution network. As I mentioned, as per the most recent code of practice, this could be a solution that will work in all three previous scenarios, no matter where. And this is a screenshot from our code of practice, where you have a single mini pillar, and that can feed a total of 4 EV charge points, or could be a dedicated mini pillar for EV charging only. Public on-street charging, as we know, in an urban area is usually with capabilities to supply around 2 or by 22 kilowatt AC to an EV charging point. So you may have maximum of 2 per charge point. Yeah, here. Moving on from the on-street, but still on the public charging topic, we can briefly discuss the charging hubs, and they are of great importance for the electrification of transport, especially for motorway and long journeys. As we know, the motorways and driving an EV on the motorway will consume more quickly your battery and will shorten the range. So that's important to have these public charging hubs to recharge our EVs. This is also acknowledged in the latest strategy infrastructure document issued by the Department of Transport. And obviously, with the exponential increase of the EVs on the road, it's expected that the number of the fast charging hubs will also increase. Now, what we have done, hubs are obviously, they are great. They are very fast chargers, but they require significant power from the electrical infrastructure. And our ESB Networks engineers have developed a solution to future-proof the EV charging for the hubs. Now, as you can see there, the ESB Networks equipment is located within the customer module. It's adjacent to the customer medium voltage circuit breaker compartments, and the module is owned and maintained by the EV charging supplier. This solution is currently being trialed in a few locations around the country. Moving on from to the last probably of the public charging category, which is charging in apartment blocks. As you can see in Ireland, the number of apartments is relatively low, and the private apartment ownership represents only 20% of that 12% total number of apartments. What is really good, as you may know, the government issued last year a statutory instrument regarding installation of charging points, and it's called SI 393 by 2001, and it stated that a building which has more than 10 car parking spaces shall have installed at least one recharging point and ducting infrastructure for at least one in every 5 car parking spaces to enable the subsequent installation of recharging point for EVs. Also, they are saying there that a building which has more than 10 car parking spaces that is new or undergoing major renovation shall have installed ducting infrastructure for each car parking space to enable the installation of recharging points for EVs. Now, for these cases, and following the public consultation initiated by SEAI, ESB Networks has submitted a response paper detailing the proposed solution. And here is a picture of an underground parking, and in yellow is shown the electrical circuit for the charging infrastructure and the associated charging points or sockets. On this slide is shown exactly the same thing, but is the electrical schematic associated with the setup presented on the previous slide. And here I'd like to refer again to the code of practice, as this schematic is in line with this and has its dedicated supply and a dedicated meter for the entire charging circuit. As you can see, there is the ESB substation. You have the main board with a dedicated circuit for charging, which is metered. This arrangement can be used for multi-story car parks, for office blocks car parks, or apartment blocks multi-unit developments. Now that we have I think we have covered the most common public charging scenarios, the last topic, my presentation, is about the new connection process. And this is a fully online process for new domestic and commercial applications. Last year, we received in excess of 20,000 new connections applications, domestic and commercial, and I'm glad to say that in excess of 85% of customers submitted their application via our online portal. So I'd like to encourage to use this process, as you can see and track the progress of your application. You see there on your right-hand side, this is how you can track the progress since you apply until it's been finalized. So, and this works for everything from domestic and industrial as well. And everything is available on our website. It's just a matter of creating a profile, and after that you can log in and check the progress. It's a great system. So again, I would encourage everyone to use it. Just to finish, I listed here a few challenges, but I think with challenges come opportunities, and with opportunities come solutions. And one of the biggest probably opportunities is the switch from fossil fuels to renewable energy. And for me, the biggest opportunity is that all of us can come together and collaborate, as we need to have a shared vision on how we deal with these challenges. Because for a successful energy transition to be successful, it's going to be very collaborative effort. It's going to be a new and innovative way of doing business. So I think everyone knows that the big thing here we're trying to do is achieve net zero, and we really welcome the collaboration with our customers and stakeholders to achieve this. So I really want to thank you, and to finish my presentation,